Welcome to the Explainer. Today, we are getting right down to it and breaking apart the absolute fundamentals of Python. We're going to start from scratch and cover the core pieces you need to build your very first programs. All right, let's just dive right in. Here's what we're looking at today. We're going to start with the tiniest little pieces of code and build our way up, piece by piece, until we have programs that can actually think, organize information, and even talk to us. So first up, we're starting at the very beginning, with the smallest, most essential unit in all of programming. You can think of it as the atom of our code, the variable. Okay, so what is a variable? Honestly, the easiest way to think about it is just as a labeled box. You give the box a name, you put something inside, and that's it. From now on, whenever you use that box's name, the program knows you mean whatever's inside. It's really just a simple way to store information so you can use it later. So what kind of stuff can we actually put in these boxes? Well, the first thing is just plain old text. In the coding world, we call this a string. It's just a sequence of characters. Could be a word, a name, even a whole sentence. You just have to wrap it in quotes. Next up are integers, or int for short. These are your everyday whole numbers. No decimals, no fractions, just straightforward numbers. They are perfect for anything you need to count, like your age or how many items you have in an online cart. But, what about numbers that do have decimals? Well, for that, we have floats. A float, or a floating point number, is what lets you handle those decimal points, so it's perfect for things like height, weight, or prices. And finally, we've got one of the most powerful and simple concepts, the Boolean. A Boolean can only be one of two things, true or false. That's it. It's like a simple on-off switch, a yes or a no. And believe it or not, this little switch is the foundation for how our programs make every single decision. So this brings up a really important question. Why does Python care so much about the type of data we put in the box? Why can't we just throw everything in there and mix it all up? And here is the perfect reason why. If you try to add a number, an integer, to a word, a string, Python just stops and throws what's called a type error. It gets confused, because you can't really do math with text, right? Understanding these data types is exactly what helps us avoid breaking our code in these simple, predictable ways. Okay, so now that we have our individual boxes for storing data, let's look at how we can start organizing lots of items together in bigger containers. We call these collections. The first and most common way is with a list. And a list is, well, it's exactly what it sounds like, a collection of items in a specific order. You can add things, you can remove things, and the order you put them in is the order they stay in. Just like a shopping list or, a list of your favorite drinks. Dictionaries are a little different. Instead of just a simple ordered list, they store information in pairs. You have a unique key and its matching value. Think of it like a real dictionary, where the key is the word and the value is the definition. It's absolutely perfect for linking two related pieces of information, like a country and its capital city. All right, we've got our data, and we've got it organized. Now for the really fun part. Let's give our programs a brain. Let's write code that can actually think for itself and make decisions. So how do we actually do that? Well, we basically teach our program how to ask questions about the data it's holding. Simple questions, like, is this number bigger than 10? Or, is this Boolean value true? And then, based on the answer, it can perform completely different actions. And the if statement is the absolute heart of all this decision-making. You give it a condition, some question that can only be true or false, and if that condition is true, a specific chunk of code gets to run. If it's false, the program just skips right over it. It's really that simple. Now, pay close attention here, because this is a tiny detail that trips up almost everybody when they're starting out. A single equal sign is for assignment. It says, hey, put this value in this box. But a double equal sign is for comparison. It asks the question, are these two things equal? Mixing these two up is a super common source of bugs. So as our programs get bigger, you'll start to notice you're writing the same lines of code over and over and over again. To work smarter, not harder, we need a way to make our code reusable. And that, my friends, is where functions come into play. A function is basically just a named recipe for a piece of code. You define it once, give it a name and a list of instructions. For instance, you could make a function called hello that just prints the word hello. Then, anytime you need to say hello in your program, you just call that function by typing hello open paren instead of writing out the whole print statement every single time. It is a massive time saver. So far, all the data in our programs has been stuff that we've typed in ourselves. Let's connect all these ideas and build a program that's actually interactive, one that can have a real conversation with the person using it. And we do this using the input function. What it does is it prints a prompt to the screen, and then it just stops the whole program and waits. It waits for the user to type something in and hit enter. Whatever they type gets captured and stored in a variable. But there's a catch. It's always captured as a string, as text. And look what happens. Hey, we've seen this error before, haven't we? Because the input function gave us the age as text, like the character's 21. We can't do math on it. We're right back where we were, trying to add a number to a word, and Python just won't do it. But there's a really cool solution. It's called typecasting. We can literally tell Python, hey, I know this looks like text, but I want you to treat it as a number. By wrapping our string variable with int function, we transform the text 21 into the integer 21. And now we can do all the math we want. Problem solved. And there you have it. Seriously. With just these few concepts, you now have the complete set of fundamental building blocks for programming. You've got variables to hold data, types to define what kind of data it is, collections to organize it, control flow to make decisions, and functions to keep it all neat and tidy. This foundation right here is the launchpad for literally any path you want to take in programming. With these blocks, you are officially ready to start exploring. So are you going to go into web development and try to build a simple server with something like Flask? Or maybe you're more interested in data science, using libraries like Matplotlib to create cool charts from real data? You could even get into automation, writing scripts to do your boring tasks for you. Now that you have the blocks, the only question left is, what are you going to build?